Thanks, Lindsay. Yeah. Thanks for coming to tonight's talk on Western Washington wildfires. A little book, just to let you know that we're going to be videotaping this tonight so that we can post it on our website. Also, if you wouldn't mind holding your questions until the end, you can do the hand raise thing at the bottom of your Zoom. There's a place where you can actually raise your hand, or you can also put something into the question and answers the chat line. And then at the end, we'll actually answer those. So if you have any questions, go ahead and put those in there. So tonight, our speaker is Josh Holofsky. He's the research scientist with Washington State Department of Natural Resources. And I'm gonna let Josh tell you more about himself. So thanks, Josh, for being here tonight.
Sure, thanks, Michelle and Lindsay. Good evening, everyone. Well, I guess there's no better way to ease into a weekend than listening to a fire talk, given a global pandemic and with election fatigue. The fact that you guys have made the time to be here tells me you all have a real innate curiosity about your surroundings, or maybe you have just a little bit of some masochistic tendencies. I don't know where you fall along that spectrum, but either way, thank you all for making the time to be here. I really do appreciate it. I'm going to attempt to share my screen and right now, Michelle and Lindsay, but let me know if it's not working. Let's see.
Looks good, Josh.
Yeah.
All right, still looking okay?
Yes.
All right, well,
actually, Josh, that view went to your double screen.
Oh, it did, okay.
Yeah.
Let's try that.
That's better.
Okay, thank you.
Yeah.
Well, before we dive into the topic of wildfire, I thought I would just tell you all a little bit about myself. I was born and raised in New Jersey, which means I have really strong opinions about bagels and pizza, but maybe it was from all the years and decade and a half camping with my dad outside of New Jersey that all of those experiences really opened my eyes to the rest of the country. And over the years, I slowly migrated my way to the Pacific Northwest. Along the way, I spent some time in the Ozark Mountains of Missouri capturing lizards using lassos made out of dental floss. And when the dental floss ran out, I used thicker grass. I've spent some time in the southwestern part of the US studying fires. And then most recently, before coming to the Department of Natural Resources, I looked and studied at how the reintroduction of wolves in Yellowstone influenced both or affected both the number of elk as well as the behavior of elk, and how those changes in elk numbers and behavior in turn influenced the regeneration of aspen seedlings, which are preferred browsing species of elk. And since coming to the Department of Natural Resources as a research scientist, I've spent my time thinking a lot about disturbances, both natural and human-related disturbances, and how those disturbances really influence my agency's ability to manage our land sustainably for a whole suite of both economic and non-economic values. So it's kind of with that background and my interest in disturbances that about, I don't know, 5 years ago, managers in my agency, as well as in some of the national forests here in Western Washington, asked what really seems like a really innocuous question, right? Just how much old growth was there historically before Euro-American settlement? And what I should have realized at the time was if this question hasn't been answered for Western Washington, that there's probably a good reason for it. And what I soon realized was that if you want to know about how much old growth there was in the past, well, then you got to think about the disturbances that shape the landscape and ultimately limit or constrain how much old growth could have ever been present. And sure, we need to acknowledge and recognize the role of wind as a common disturbance along our coastal areas. But if we step back and think about Western Washington more broadly, well, the primary disturbance that have shaped these lands historically is actually fire. Now, probably prior to about 2 months ago, if you were to think about fire, your minds and my mind would immediately gravitate to the eastern half of the state. And that makes a lot of sense. I mean, just look at this map of 34 years of fire footprints on the screen. We can see that by and large, the vast majority of fires and vast majority of area burned is in the eastern half of the state. And that makes sense too. We all implicitly recognize that the climate between eastern and western Washington is different, right? And those differences in climate manifest themselves in different kinds of natural disturbances and also in different kinds of plants. So if we take the example of our dry forests in the eastern half of the state, historically, they were in this very open type of condition. And they're able to be maintained in this open condition because fire historically was very frequent in these dry forests. And it was a low intensity, cooler kind of fire that would, thin the small stuff but keep the big stuff. By having that common and frequent low intensity fire, these open sorts of conditions in our dry forests were maintained. Now, as most of you know by now, as the story goes, due to nearly a century now of fire suppression in the east side, our forests have an uncharacteristic density to them. There are a lot more trees than there used to be. And a lot more trees means a lot more fuel. And maybe we haven't altered how much area burns, but we've certainly altered the severity or intensity of those fires in our dry forests in eastern Washington. So yeah, it kind of makes sense that our minds immediately gravitate to the eastern half of the state. And probably if we were to kind of draw an imaginary line across the crest of the Cascades, could almost be excused for thinking like there was a firewall between our two halves of the state. It's why historically, newspaper articles used to refer to Western Washington forests as asbestos forests because they just didn't think they burned. But we know that's not quite true, right? If we look at this map of characteristic fire, historical characteristic fire, we can see that the majority of Western Washington is painted black, which is associated with an infrequent and high severity kind of fire. Now, what does that mean? Breaking those words apart, infrequent means that the time between the big fires that shape this landscape tend to span centuries rather than, say, years or decades like in our eastern Washington dry forests. High severity means that when you get these fires, you tend to have these large patches of stand replacing fire that tend to consume or burn up 75 to 100% of the trees in these patches. And the patches could be hundreds of acres, thousands of acres, tens of thousands of acres, even hundreds of thousands of acres or bigger. Now, of course, no fire is ever a complete moonscape. And if you would zoom out to any fire footprint, you would see a mosaic of severities. You'd see areas that barely burned at all and a gradient all the way to these large patches of stand replacing fire. But the defining characteristic of these areas painted black on the map on the screen are those large patches. So, a reasonable question is, why do we think this is how the landscape works and burns? Well, ecologists and fire ecologists have been studying these landscapes for a long time, and they have a pretty good idea of how these forests grow and develop. And they tend to burn with a significant stand replacing component every 200 to 600 years. But we don't have to just look at these beautiful hand-drawn illustrations. We can actually go out on the landscape today and look for legacies or fingerprints of past fires. You just need to know where to look and what to look for. Now, the where to look is probably kind of obvious. You have to go to those places that haven't been managed. As far as what to look for, well, that takes a little more adjustment of your perspective. What you want to look for in these landscapes are changes in the texture and color of our forests, which designate differences in the ages of our forests. And I'll show you what I mean by zooming into that middle photo in front of you on the screen. So when I look at this photo, I see two distinct ages of forests. I see old growth forests right by those arrows, and they have a darker color, a darker green and rougher texture to them. But between these two islands of old growth are a veritable ocean of lighter green and smoother textured trees. And they're lighter green and smoother textured because they're younger forests, all about the same age. And they're all about the same age because those areas burned during a stand replacing event about 120 years ago, and just simply to the vagaries and topography and fire weather at the time of the fire, these patches of old growth didn't burn. And of course, we have more recent contemporary examples of these fires. We have the 2017 Eagle Creek fire down in the Columbia Gorge, and you can see that characteristic large stand replacing patch pattern. And fresh off the presses, some colleagues and I have recently classified the western half of the Norse Peak fire, which was also in 2017. Western Cascades, not too far from Crystal Mountain. It burned about 25,000 acres. And what you can see in this burn severity map are, again, those characteristic large patches of stand replacing fire that are colored or painted black. And these are thousands and thousands of acres in size. But of course, we can also see that, like any fire, it's a mosaic of fire severity, right? There's also low and mixed. So that's kind of the basics 101 about the very superficial level of fire and forest ecology. But a natural question to ask is, how big were the largest fire episodes? Because again, you can't estimate how much old growth there was in the past without knowing how big these fires could get. And if you think about it, this is actually a really hard question to answer, because by definition, these fires are infrequent, meaning we don't have many samples or examples of them on the landscape. By definition, these fires tend to be high severity and stand replacing, which means more recent fires tend to burn up evidence of past fires. And of course, Euro-Americans up through today have greatly modified and erased signatures from past fires. So really, and unfortunately, the only way to estimate how big these fire episodes can be is through math. And I'm sure there's some virtual palm sweating going on when I mention math on a Friday evening, but I promise you this is not going to be painful. I presented this sort of exercise to policymakers, and assuming some of those policymakers, no offense if any are on the phone, are also not very math adept. I'm not very math adept. You know, the ideas and the math that we're presenting still got through. So let's just go through this. No trick questions here. If we look at the map on the left, you could see a lot of colors representing different forest types in the North and West Cascades that I'm just going to group together to call the West Cascades. And it represents, say, about 6 million acres. And according to the literature, sometimes it takes 500 years for the whole landscape to burn, which we call the fire rotation. So here's the math exercise. If you had one fire during that 500-year period, how large would that fire have to be? Now, luckily for you, we're not in a room together, so I can't wait for the awkward pause until someone pipes up with the answer, so we'll just walk through it together. But if you think about it, if you only had one fire in 500 years, and your whole landscape has to burn by definition in 500 years, that means that one fire would have to burn up your whole landscape, which means that one fire would be 6 million acres. Okay. Well, what if we had two fires in that time period, which would come out to an average of one fire every 250 years? Well, let's see. Each fire would burn half of your landscape, which means each fire would be 3 million acres. All right, it's a big number. What if we had a fire every 100 years, which would make 5 fires over that entire 500-year period? Well, each one of those fires would be, on average, 1.2 million acres. Right? And it doesn't matter. We can keep going through this exercise. Like if we had a fire every 25 years, which is pretty frequent, right? Or 20 fires in that 500-year period, we're still talking about 300,000 acres burning in every 25 years. right? And this is all based on some simple math based on what we know as the fire rotation of 500 years and just some landscape area. So I think you can get an idea for where I'm going, but maybe some of you realize that this math is maybe a little too simplistic, right? We're not going to have exactly 20 fires that are exactly 25 years apart that are all exactly 300,000 acres. And so there's actually a slightly better way to do this math. And I'm not going to go into the details, which you can thank me about later. But before I talk about that other way, I want to take a detour in a topic that is often associated with fire. Talk about floods. Now, the reason I want to talk about floods is because we're much more familiar with flood terminology. We've all heard of the 100-year event, the 100-year flood that has a 1 in 100 chance of occurring any year, and it is associated with flooding a certain amount of area. And the 100 event happens much more often than the rarer 500-year event, that while more rare, when it occurs, it tends to flood a much larger area. Right? So we're familiar with this terminology and the idea of 100-year and 500-year events. And what we can do is use the same mindset of events, frequency and event size, and use the same math that's used in floods to estimate fire events. Now, fortunately for us, there's nothing in the literature to indicate there's a 500-year fire event, but there's certainly enough evidence that there's a 100-year event, even a 200-year fire event, as well as more frequent ones like the 50 and 25-year. And when we apply to the same math that we use for floods, what we find is those rarest 200-year events maybe burned 1.7 million acres or so. The 100-year event, maybe 500,000 acres. And then you can go through to the 50 and 25-year events. Now, just to put some of this in perspective, that 25-year event, well, that's really similar to that Eagle Creek fire I mentioned earlier that burned in the Columbia Gorge. And, you know, I've started to think of these 25 and 50-year fire events kind of like the small and moderate fires, and those 100 and 200-year events as the big fires. And I should pause and admit and acknowledge that, of course, like a flood, no fire is small when it affects you personally. So I'm not talking about the human dimensions to these fires. I'm thinking about the ecological side. And from the ecological side of things, those 25 and 50-year events, they're just kind of a drop in the bucket. But of course, figuring out fire size isn't quite as simple as what I just conveyed to you, because as we saw earlier, there's some ecological evidence that these forests have a fire rotation or burn up every 200 years. And other parts or other times they burn every 600 years. And you can imagine that your fire size would be different if your whole landscape had to burn within a 200-year window versus a 600-year window. And similarly, we saw your fire sizes also vary depending on how much you assume fires cluster, right? Are we talking about one mega fire that happens once every 500 years? Or are we talking about lots of little fires? So really the way at maximum fire size is to run a sensitivity analysis and make a bunch of assumptions based on the literature. And that's what we did. We ran 9 fire scenarios where we assumed more fire clustering or less fire clustering, and shorter and longer rotations. And we just did different combinations of this to try to put sideboards on how big these episodes can be based on ecological and fire history studies. Now, these are the numbers we got for the largest fire episodes. And I always like to start off by telling folks that they should not bother trying to memorize these numbers, because I can assure you they're wrong. But I always encourage people to count the number of zeros, right? Because we certainly think we have the right order of magnitude. The inevitable conclusion that we came to based on culling all the literature and applying this simple math equation is that the biggest fire episodes in the West Cascades burned hundreds of thousands, not millions of acres. Now, when I started presenting these results several years ago to folks, I have to admit, I always got a little nervous because, these aren't trivial amounts. But what always made me feel better was to remember that I'm actually not the first to say this, nor are my colleagues. We think there was a fire episode around 1700 that burned more than 1 million acres on the Olympic Peninsula and between 3 and 10 million acres in Western Washington. Many of you may be familiar with the 1902 Yakult complex that burned north of 1 million acres in parts of Western Washington and Western Oregon. And then more recently in Northwest Oregon is the Tillamook burn of 33, which burned 350,000 acres, right? So all these examples fall within our estimates. Not only do these estimates and records fall within our expected ranges, but a little more recently, some scientists took that characteristic fire map I showed you earlier, and on top of that, overlaid public land surveys that occurred at the turn of the 20th century. Now, for those of you unfamiliar with these land surveys, they were funded by the federal government, and they were done to just assess the land around us. And so at regular intervals, people would stop and in a notebook record the quality of the timber, the species of timber. And they'd also record the presence or absence of fire. It could have been recent fire, it could have been older fire, we don't know. It was just evidence of past fire, and we think it was evidence of past stand replacing fire. So when you overlay those burned areas, those pink areas on top of the infrequent and high severity, what these researchers found was that in that area painted black, the largest patch recorded of burned area was also a little over 1 million acres. And they recorded 5 patches over 250,000 acres. Again, all really consistent, right? And so as my colleagues and I started going through the literature and reading about the more recent events from 1900 onward, we kept realizing and noticing that certain factors would come up over and over again. And I just wanted to share those with you. We noticed, first of all, that these fires tended to occur late in the summer, say mid-August through September, maybe even early October. And that kind of makes sense. That's after our forests have had a season of drying out. And of course, this next factor is supremely obvious, but it has to be mentioned because your forests can be bone dry, but they'll never burn without an ignition source. Now, while most of us immediately think of lightning as the primary ignition source, as it is in many other locations in the Western US, in actuality, here in Western Washington, at least for these 40 years of records that I feel confident of, on average, 90 to 95% of all fires have been caused by us, people, not lightning. And of course, those two ingredients are enough to get any fire going any time of year, but especially late in the summer. But the key ingredient to getting one of these big fires are something called synoptic east winds. Now, for those of you unfamiliar with these sorts of wind events, typically our winds blow in from the ocean across the West Cascades and into Eastern Washington. But during these synoptic east wind events, those patterns reverse. So imagine it's dry late in the summer. You get a synoptic east wind suddenly blowing really hot and dry air from Eastern Washington or Eastern Oregon or interior British Columbia, blowing across the West Cascades towards the ocean, drying out already dry forests, dropping the relative humidity to incredibly low levels. That's when you can get the big fires in a really short amount of time. I want to show you an example from that Tillamook fire that burned 350,000 acres in total right now. What you see on the left is a map of daily fire perimeters from that fire. And I know there are a lot of colors, and don't worry about any of the colors, but what those colors by that arrow indicate are all the fire perimeters from August 14th through August 24th. So you can see that for that 10-day window, the fire was pretty well contained in a small area. And then on August 25th, and 26, that's when the fire blew up. And just look at that red perimeter. So if we think about our three ingredients with this Tillamook burn, what we see is it occurred in late August. Yep. The ignition source again in this case were humans, people working in the woods. And it blew up on the 25th or 26th during a big east wind event. It's how this fire was able to burn 200,000 acres in a day, which comes out to almost 2.5 acres a second. And it's how the Yakult complex was able to travel 30 miles in a day and a half. Now, maybe before this summer, many of us weren't really familiar with these east wind events up here. But I am sure we've all heard of the Santa Ana winds or the Diablo winds in California, right? Those are the winds that make these fires explode and become really hard to contain and create a challenging fire environment. Well, the Santa Ana and Diablo winds are also these synoptic east wind events. It's just they occur so much more often in California that they have a more poetic name for them rather than we do up here because they're so infrequent. And so, I've started to think about these wind-driven fires kind of less as fire events and more like wind events that we can't control that just happen to have fire within them. And I'd say up until a year ago, my colleagues and I were really happy with ourselves for kind of putting this narrative and story together that's consistent with the evidence and records of earlier fires. And then I came across this kind of dry sounding title called Frequency of Dry East Winds over Northwest Oregon and Southwest Washington. And this was a study that was hard to find because it came out more than a half a century ago. But in this paper by Owen Kramer, he actually observed the same thing of severe easterly winds and the large forest fire link in Northwest Oregon and Southwest Washington, exactly what we're talking about. But to do one better than us, he actually measured the number of east winded days where the winds were above, I think, 25 miles an hour, or I might be wrong, and recorded those for different months of the year. So Mr. Kramer looked at the average and also the maximum number of wind days. And what you can see along the bottom of that graph is I kind of circled what some may consider the summer months. I may have been a little liberal in including June, depending on how you feel about when summer officially begins. But what Kramer also found was that the big wind events are most frequent in mid-August through September and early October. And so to me, this was kind of a humbling realization that a lot of ideas aren't necessarily new in ecology. And while we didn't come across them, I feel obligated to acknowledge them. So before the 2020 fires, and maybe even after the 2020 fires, since they happened in Oregon rather than up here, I would often get questions like, yeah, okay, those kinds of fires have happened in the past, but there's no way they could happen today because of all these reasons you see on that slide. And I have to say, without wind, I think there's a really strong argument for some of these, but let's think about each of these topics, beginning with fire suppression in light of these east wind-driven fires. Right? So the argument for fire suppression is we've got fire trucks and we have planes that can drop fire retardant, and we have incredibly brave individuals who will risk their lives to help contain and suppress fires, and they play an incredibly important and valuable role. Thankfully, they're willing to do this. But guess what? If you're an incident commander on these fires, and these fires are burning almost 2.5 acres a second, do you know what you tell all of your people? Get out of the way, because there's nothing you can do to stop a fire when it's being driven by such strong winds. So sure, fire suppression has a role, and all of our tools do, but I would argue that it's almost a non-factor when the winds are high. What about modern infrastructure? We have 8-lane highways of pavement. We have forest roads that all play incredibly important roles in containing fires, right? They're often our fire lines to try to stop the spread of these events from getting bigger. I'd say, yeah, that's true. But then my mind goes to the 2017 Eagle Creek fire, which for those of you that don't remember was ignited in September, I think September 1st, right? So it's within that window, by humans playing with fireworks in the woods. And there was an east wind event. And while that is considered an Oregon fire, what you see in this slide are actually both Oregon and Washington forests burning. So essentially, wind blew embers from the Oregon side of fire across what some estimate to be a mile-wide section of the Columbia River to ignite our forests here in Western Washington. So if a mile-wide body of water can't contain these fires when the winds blow, what's an 8-lane highway of pavement gonna do, or a forest road? So I would argue modern infrastructure, while really important when we don't have the winds, doesn't really make much of a difference when those winds are present. What about fuels management, right? We've been talking about how a century of fire suppression has fundamentally altered our dry forests in the eastern half of the state. And you can argue with some confidence that we have almost an ethical responsibility to go in and thin those forests, to make them more resilient to fire and climate change, and to return those forests to a more natural condition. I don't argue with that at all. But remember, we're here today not to talk about those dry forests, but to talk about the forests in Western Washington, which are some of the most productive and biomass-rich forests in the world. That means they're also really fuel-rich, and they're naturally fuel-rich. Fire suppression doesn't increase the level of fuels and make these fires more stand replacing. That's already the natural sort of condition for these forests. And because they're so productive, how would you ever be able to successfully thin a large landscape to manage the fuels, right? These forests are so productive, you have to be a Sisyphean task to continue to manage and thin those forests. And even if somehow you were successful across a broad landscape, well, congratulations. You've just created a forest with no historical analog across most of Western Washington, and you've disassociated the myriad of socio-ecological and cultural values we place on these older forests, or these forests here in Western Washington. Put another way, here is a photograph of different stages of forest growth and development. I personally don't see a place where forest management would make these forests less dense or less likely to burn. So while fuel management may have a place in some locations and at some scales, finer scales, I would argue that it's less relevant here on the west side than it is in eastern Washington. How about climate change? Well, I promise I'll get to climate change, but I first kind of want to wrap up talking about our west side forest just a little bit more. And I want to start off by reminding people that much of the old growth we have remaining on our landscape today in Western Washington, it was birthed from fire in the past, right? These are landscapes that are adapted to stand replacing fire. It's a natural part of the system. And sure, our forests may not be very resistant to fire, meaning they tend to burn when a fire occurs. They sure as heck have been resilient up until now, meaning after they burn, if they're given enough time, they'll eventually return to this old growth condition on the landscape. And so my colleagues and I have started thinking about these east wind driven events a little bit like we do earthquakes, right? We know the big one, the full rip 9.0 Cascadia earthquake is inevitable. It's gonna happen sometime. It could be tonight, Might as well happen in 2020, given the craziness of the year, or it could be a decade or more from now, or even centuries from more. We don't know when it's going to happen. We just know that it is inevitable and will happen. And when it occurs, it's going to have a fundamental and incredible impact on society for years, if not decades. But even with me saying all that, I imagine that most of us don't panic about the thought of this earthquake. And we acknowledge and accept the risk. We plan and prepare for the risk. And then we move on with our lives. Well, I would propose we think of these east wind driven fires the exact same way. Like an earthquake, we know these sorts of fires are a natural part of the landscape and they're inevitable. We can't really predict very far in advance when they'll occur, although it is some advantage to know we might be able to look at some of the fire weather before to give us a few days notice. But at these big fires, it could happen next year or decades from now, or maybe even longer. We just don't know. Like an earthquake, it's going to have an immense impact on society for years, if not decades. And I would like to propose we don't panic about thinking about these. Our forests are not in a crisis from a fire perspective. We acknowledge and accept the risk. We plan and prepare for the risk. And we move on, like we do with earthquakes and tsunamis and volcanoes, right? We're doing this all the time, subconsciously or consciously. It's just that we now have to add these sorts of fires to the list. So let's talk climate change. At this point in the evening, I don't want to inundate you with graphs of projections of what's happening. I'd like to actually just go through a logic exercise with you about potential climate change impacts in light of these three factors that we believe are closely associated with these big wind-driven fires. Okay. Climate change projections are consistent in indicating our futures are going to be warmer, and they're going to be especially warmer in the summer. And many, but not all projections also indicate an extension of that warm summer period. So if your summers are going to be warmer and it's going to be longer and potentially there may be more frequent droughts, well, to me, that increases the risk of fire. Well, what about ignition sources? Well, I'll tell you that in my mind, the climate change lightning connection science isn't fully settled. We have one study regionally put out by UW that doesn't find any statistically significant increasing trend in lightning. But then there are also regional level studies that do suggest lightning in our region will increase. So again, I don't feel like the science is settled on lightning and climate change. But I'll tell you what, even though it's not necessarily related to climate change, the population in Washington is expected to increase by 2.5 million people in the next couple of decades. And assuming what? At least 1 million of those people settle here on the west side, well, that means there's potentially 1 million more ignition sources, which only increases the risk of fire. So based on just these two factors alone, we can reasonably and easily conclude the area burned from fire is probably going to increase in our region. And that's actually consistent with all the fancy models out there, some of which I've run myself, so I'm not denigrating them in any way, but just logically, it makes sense. But the question is, what about these big events driven by these east winds? Are those going to become more or less frequent with climate change? And the answer is, we still don't know. And we still don't know because people haven't thought to ask the question. And some colleagues and I have some grant to answer this. And so we hope to have an answer in the next year about this question, but without knowing if winds are going to become more or less frequent. And even if they become less frequent, thinking about how that interacts with an extended late summer condition or dry condition, it's not necessarily intuitive. We can't answer this question of whether these east wind driven fires are going to increase, I'm sorry. But we can still conclude that area burned is going to increase whether or not those winds are present. So now I want to take a moment to talk about the 2020 fires. Some of you may notice that I've only obliquely referenced these fires. Some of you may notice I haven't included any actual photographs of these fires. And the reason for that is because it still feels really, frankly, really raw to me. I was emotionally hurt when these 2020 fires occurred, like I'm sure many of you were. Like many of you, I recreated in some of these landscapes that I watched burn up. Like you, I had friends or acquaintances that had to either prepare or evacuate from the fires. And maybe like some of you, you've had acquaintances or friends that actually watched their homes burn. So there was a real physical reaction to these fires for me, as well as an emotional one, which is why I still can't bring myself to show photographs of these fires. But I still feel an obligation to talk about them, because if you read news articles and quotes from various people, or if you read op-eds in the local or national papers, you get really conflicting messages. Some op-eds and people claim these are climate fires. Others say it's not climate change at all, it's forest management, right? Or forest mismanagement. I've actually read articles, one stating that if we had been able to manage our forests more aggressively, these fires wouldn't have happened. But on the other hand, I've read articles that said these fires were as bad as they were because of the historic way we manage these forests. So which is it? The term unprecedented with the 2020 fires was also bandied about quite a bit. So I'd like to take the knowledge that I've shared with you, that we've gleaned in the first part of this talk, to apply that knowledge to look at the 2020 fires. So the first question, because it was mentioned so much this summer, is, were the fires unprecedented? Well, last time I checked, the fires in Southwest Washington and Northwest and Western Oregon burned roughly 500,000 to 750,000 acres. Well, that seems to be entirely consistent with the historical record. So from that perspective, these fires don't feel very unprecedented. Well, maybe we could argue they were unprecedented in the areas that burned. So I want to take this characteristic fire map with those early surveys overlaid on top, and all I'm going to do is erase all those colors and make it a boring gray, and change those hot pink colors of the early land surveys and make them blue. And now what I want to do is overlay the 2020 fires on top of that. Well, kind of looks like some of the areas that burned in 2020 did burn in 1902. But maybe we should make sure of that, and I'm going to zoom into that area I now have in that ellipse to see how that kind of pattern plays out. And once you know it, every single fire that burned in 2020 also has a record of fire from the 1902 survey. I think these fires were unprecedented, because of us, because we are living in these areas in such great numbers. That's what makes these fires unprecedented. Ecologically, I would call the 2020 fires rare, but with precedent. What about thinking about these fires from a forest or fuels mismanagement, either wherever you fall in that spectrum, not enough management or too much? Well, remember, we learned that we're talking about some of the most productive forests in the world that are naturally dense, and means they're also naturally rich in fuels. They're rich in fuels with forest management. They're rich in fuels without forest management. We're not living in a system that's limited by fuels here in Western Washington. or those parts of Oregon. So I would argue that these fires could have happened irrespective of how we manage these forests. And remember, we can't just apply Eastside principles at a broad scale because these forests are so productive, and thinning those forests again wouldn't be sustainable across broad scales. Now, maybe it's not quite the best comparison, I'm not sure, but it felt okay to me. Another way to think about treating broad landscapes brought the Paradise Fire in California to mind, recognizing it's a very different system and it's more like our dry forests. But for the town of Paradise, they did everything right in trying to prepare for fires. They did everything right, from having big fuel treatments around their towns. They thought about this. And what you see in this thermal image is what the LA Times article poetically called a blizzard of embers, flying over those fuel breaks, igniting those houses. Again, just to emphasize the idea that, yeah, we can manage our forests for a whole variety of reasons. Yes, fuel breaks can make sense in these stand replacing systems in some locations and under some circumstances, but it's hard to argue that those sorts of fuel related treatments would have slowed down or stopped the spread of these wind-driven fires. So here's the big one. Was it climate change? Well, what we know about these fires is that they occurred when that part of Oregon was in an extended drought. And we also know that the forests, and therefore the fuels, were much drier than average. Now, both of those statements are entirely consistent with what we'd expect with a changing climate. But they can also have happened from time to time in the past, and it could have been just natural variability this year, even though it's also consistent with climate change. The point is, we can't tell if this was climate change related or not. But what we do know is that these fires have occurred in the past, and climate change isn't and wasn't a necessary precursor for them to occur, right? If climate change never existed in an ideal world, I still would have expected those fires that we saw in 2020 this year. And none of it is surprising. Doesn't necessarily mean that climate change wasn't a factor. I don't know if we can tease that out, but I certainly wouldn't call these climate fires. Often after these fires, people rightly and reasonably ask, will our forests recover? I personally had that question when I visited the Norse Peak fire that happened in 2017 up by Crystal Mountain, because this is what I saw. It did look like a moonscape. Again, not everywhere, but in a lot of places. And I'd step in the soil and my foot would sink in like a foot or more of ash. And I thought, holy cow, how are these forests going to recover? And I went back to Norse Peak this summer. I'm already seeing things happen. Plants are coming in, not everywhere, but in a lot of places, right? And we'll have to see how the Norse Peak fire responds further into the future. But if we head up north to the Goodell fire that burned in 2015 up in the North Cascades area, and that's still in Western Washington, there's a lot of growth there. So I guess my message to folks is that these forests will recover. They will. It may take some time, but they will. Again, this is how they've operated in the past. So I'm not going to go into a lot of detail about what you can do, but it really depends on whether you're thinking and preparing for those smaller fires or those larger, rarer wind-driven fires, right? If you're preparing for those smaller fires, you can actually apply a lot of the what's known as fire-wise principles, which includes hardening infrastructure around your home, such as replacing wood shingles with composite or metal roofs. And there's many other things that you can do. And you can change what you do depending on how far you are from your home. We can also continue to suppress fires aggressively and detect them aggressively here on the west side in most locations where society and humans are at risk. Again, we don't have the same negative ecological consequences for suppressing fires here on the west side that we do in our drier eastern Washington forest. But then if you're planning and thinking about the big one, really the best things you can do is think of your access in an emergency. How would you leave your home? And it's no different than thinking about how you would leave your home from an earthquake, right? And the more pathways and routes you have to access to leave, the more options you have, the better. And we also need to think and work closely with our emergency responders, because these wind-driven fires are really an emergency response opportunity. And just like they prepare for these other natural disasters, they just need to start to add these wind-driven fires into their management plans. And I guess one of the last things that we can do is just be a little humble. Accept the fact that we won't be able to avoid or mitigate all fires, right? Just like part of the reason where many of us are attracted to this region are the snow-covered volcanoes that have a very explosive potential beneath us all, right? Our forests are wondrous places, but they also have a fiery and violent origin, and there's a risk in nearing with them. But it's probably on a conscious or subconscious level in the contract or in the brochure of living in this really beautiful part of the world. And it's just one of those risks that I'm personally willing to take for having the opportunity to live here. So with that, I think I'll end, and I thank you all for your time, and I'll be happy to take questions.
If anyone has questions, oh, I do see one. We have Robert has raised his hand. I will allow you to talk now, Robert. Go ahead.
Oh, I think Robert's on mute.
Okay, do you hear me now?
Yeah,
Yes.
I do.
Okay, so seems like, I mean, what your argument makes a lot of sense. I mean, we've gone more into the wilderness areas. I mean, I've had relatives do it and realized that it was safer to live closer to town and all that. But how do we get people out of that? I mean, we see it. I mean, I work on rivers and I know all about the floodplains, and everybody wants to build there. And, trying to get people to realize that, that they may be scenic areas, but they're putting themselves in harm's way. I mean, how do we get people to change this paradigm of, oh, I got to go to the most scenic area regardless of the risk? I mean, it just seems like the age-old question.
Yeah, I don't know if you change the paradigm, but what you do is, I guess, you educate, right? We have Earthquake Preparedness Month. We have, and even a time where we're all supposed to, on a specific day where we get under our desk or wherever we are to practice. I think it's just as much about getting the message and acknowledging and recognizing it's a risk. It's a low probability, high impact sort of thing, right? Just like volcanoes and earthquakes. So I think it's as much about getting the message, because people are going to live where they want to live. It's in Eastern Washington. It's what contributes partly to the fire risk and some of our inability to manage the way we want because of the smoke and other issues. I don't think we're going to change where people live as much as just informing them of possibilities.
Well, to add to that, do you think the insurance companies will get more involved with that? Because, they're going to lose money on all this stuff. I mean, from a business model, how long are they going to promote basically, inappropriate behavior, from a risk standpoint?
Yeah, so I know in California, insurance companies were dropping policyholders, and I believe that just in this last election cycle, something passed, and I may have this wrong, that actually prohibits that from occurring right away. So I think they want some other mechanism in place. I know some insurance companies won't even in Eastern Washington actually offer landowners a policy unless they practice and implement fuel treatment reductions and fire-wise principles around their house. So I think it's becoming more and more reasonable and expected, and I'm sure it'll continue to do so. It's really no different than other potential climate change impacts, from sea level rise to flooding. It's all going to be factored in by those insurance adjusters one way or the other eventually.
Sure, thanks.
Yeah, thank you.
We have Martin with a question. I'll allow you to talk, and just remember to unmute yourself.
Here we go. Hi, can you hear me?
Yes.
Sure. I'm glad we're making this a family affair.
Question for you. The one variable that's changing is now that we do have global warming, is that shortening the cycle, or we don't have enough time yet to find that out? In other words, instead of every 500 years, maybe it's every 400 years or every 300 years. I just don't know. Are the cycles being shortened?
For these big fires, we can't answer that question because we don't yet know if fire frequency is going up or down for those wind events. But if you think overall, if area burned is going to increase in the future, that would still imply fire is going to be more frequent and those cycles will be shortened. The question is how much, right? If you're going from a 500-year fire rotation to a 400 or even a 300-year rotation, doesn't really fundamentally alter your forests that much. They're still going to look the same. It's just, so what the question is, how much of a shortening of that cycle is going to happen? And, we can't quite answer that part yet.
Will the forest still have enough time to mature so you'll have a complete cycle? In other words, how long does it take from the time of a burn till you have complete maturity? How long would that take?
Let's see. So the early succession or early seral time, which is defined as the time after a fire until the site gets inundated and completely filled in with tree seedlings. That could be as short as a decade, but it's also been estimated to be as long as 50 years. And then from that point, to grow a forest that begins to resemble old growth forest takes another 80 to 120 years, depending on where you are. So there could still be time, and there should still be time in a lot of places, right? Because we're not talking about every place burning all at once. It's gonna be in patches, just like it is in the eastern half of the state. And they're actually, what we're thinking is, there are some places that are more prone to burning than others, and that's a current active area of investigation for us. And those areas that are more prone to burning tend to be associated more with the large passes, like by the Columbia River and some places that burn in Oregon that can help funnel that east side air to the west side. And luckily, we have some of those places in Western Washington, but luckily it doesn't appear initially to be as prevalent as it is in Oregon.
Thank you.
And we did have one comment in the chat. Josh, Marion said, fabulous presentation.
Oh, well, thanks, Marion. I appreciate it. I should also note that if anyone has any questions, Lindsay and Michelle have my email address, and any of you or all of you are welcome to contact me, and we can talk over email, or we can set up a time to talk on the phone if need be.
Thanks, Josh. That was great.
We do have one more question. Kristen just raised her hand, so I will go ahead. Kristen, you can go.
Yeah, thank you. I was curious in terms of the fire succession and stuff like that. And the pictures that you showed of old growth and not so old growth, where does our forest harvesting fit into this cycle in terms of logging and clear cutting and that kind of thing?
Let's see. So on private industrial lands like Weyerhaeuser and companies like that, they tend to have a rotation, I think, between around 35 or 40 years.
Right.
So if your question is, are you asking, so those are still pretty young forests within the scheme of a forest life cycle. But if you're asking, are you asking if that makes the forests, those sorts of rotations make the forest more or less prone to burning? Is that your question? Or?
Yes.
Okay. During these wind-driven fires, I would say no, it does not. You know, outside of these wind-driven fires, the answer is I don't know. We know there's a study down in Southern Oregon, so it's a much drier and warmer place, that did show, there are a couple studies that have showed industrial forests burning more intensely and severely in a fire than other forests. But again, that's a Southern Oregon, different sort of forest system. I don't know how well that applies up here without the winds. Sorry.
So does if the forest is a more mixed forest, does that have any effect on fire? I mean, everything just burns, whatever is there, no matter whether it's all Doug-fir or.
So during these wind-driven events, it typically doesn't matter what your forest composition or structure is, but you know, some good strategies in general are to promote forest diversity. Hardwoods have been known to be fuel breaks without winds. So there are things you can do that may or may not help, right? Structural diversity, different forest ages, different species mixes, that can all help potentially mitigate some fire risk and spread. It's just, you know, it's all about a risk reduction strategy. It's never a guarantee that it's going to do something. But, you know, when you diversify your landscape, it's just like the stock market, right? You don't put all your eggs in one basket, and it helps facilitate forest recovery by having a diversity as well.
Mm-hmm. Okay, thank you.
Yeah.
I don't see any more hands raised. So any last call for questions, anybody? I think we're good.
All right.
So we will be posting this on our Stream Team website. So it should be up within sometime next week, probably. So.
All right. Well, thank you all again for hanging in there on a Friday evening. I really appreciate it.
Yeah, me too. Thanks, Josh.
Yeah, you got it, Michelle.